Okay, so let's see if we can really quickly talk through some concepts of lengths and dot products for vectors. So first things first, we need a definition. The vector v, and I'm going to say that that vector v is made out of components x1, x2, up to xn. Everybody with me on that? So you have numbers in a little box arranged as a column. In our n has a length or magnitude denoted as mag v given by mag v equals, you guys remember? How do you figure out how long a vector is?
You use the distance formula and just square all of the terms of the vector under a square root bar.
Good. Square the components.
And add them, yeah.
So square all the numbers in your vector, add them up, and then square root the whole thing. Okay, that's one definition I'm going to need. The next definition I'm going to need is a dot product. So the dot product of, and I'm going to do this. I'm not sure this is faster. Oh, it's not faster. I thought it was going to be faster. So, and W, Y1, Y2, up to YN is denoted V dot W. Okay, everybody familiar with V dot W from some previous thing? Maybe? Okay, good talk. So V dot W given by V dotted with W is, oh yeah, how do you do a dot product?
The product of the respective terms in each vector all summed together.
Okay, do x1, y1, so that's first component of V times first component of W, plus x2, y2, plus da da da, keep multiplying and adding until you get to the end, and you do xn times yn. Please note they have to be the same size in order for the dot product to be defined. If they are not the same size, the dot product between two vectors is not defined. Does that make sense? Okay. Lemma. Is this a new word?
For me, yeah.
Okay, red. So a theorem is a piece of mathematics that is a consequence of some definitions that takes a proof. With me on that? A lemma is a small theorem, essentially. So this is like a little baby theorem. Oftentimes they don't take much in the way of proof. And in this case, I'm going to give just a little proof just because I feel like I should. So my lemma in this case is going to be that the magnitude of V squared is V dotted with itself. You guys see that?
That makes sense.
Yeah. So proof. How would you prove this?
You could just kind of like write it out the way we were writing it out before.
Yeah. We'd say something like, let V equal, oh, actually. Uh-oh, where did that go? Good. Be like, yo, dude, let V be this stuff. Then V dot V is x1 x1 plus x2 x2 plus up to xn xn, which is x1 squared. Do I need to tell you why this is the squares added together? This is actually a kind of a perennial problem with proof writing. If you're going to try to prove something, oftentimes you don't know what level to go down to, right? You can't go to the bottom every time. You don't want to explain to me why the magnitude squared is equal to the dot product by going to goats, which is where all of math comes from. We don't want to bring this down to counting goats. That ain't going to happen, right? So you got to go to some reasonable depth so that your reader understands. The reader that I want you all to use in your head is one of your classmates, preferably whoever you think is slightly dense, but not dumb. Good. So like, I'm gonna aim at Zach. No, I'm just kidding. I'm not gonna aim at Zach because he's your embedded tutor. Also, he's not dense. So just, you know, hypothetically, one of your classmates who's just a little bit struggling on what this concept is, right? Just think of the time that you've been stuck and just think, how deep did you need to go? Do you need to go to algebra? Probably not. Do you need to go to arithmetic? Definitely not. Might you need to go to, you know, a definition that's on a page number? That might be good. You guys all kind of with me on that? Okay, so I've got this, and then I say, oh, and that is the square root of that. Uh-oh, we're gonna try something wild. It's not gonna work, but we're gonna try it anyway.
It's too long, Joe.
Damn it. Well, I know it's too long. I was gonna shrink it.
You genius.
Yeah, damn it. Contrary to obvious fact, I have actually been practicing a little bit with my manipulations here. It's not good yet, but it's getting better. All right, so this is all that crap squared, right? And that is the magnitude of V squared. Just with me? Now, at the end of a proof, you get to do this cool thing, which is you draw a little box and then you put a couple of hashes in it because you're done. Some people write QED. Those people are pretentious. And you should judge them. I don't know what string does.
See it on math memes.
What was that, Jake?
Is that why I always see it on math memes, to make fun of the pretentious people?
Yeah. Yeah, for sure. Yeah, QED stands for Quad S Demonstratum, which is some dead language bullshit for I showed this. I mean, really, honestly, they may as well be writing, yo dog, it's done, and also I'm pretentious. All right, so does everybody believe that this kind of meets the standards that I laid out about explanations? If you feel like if you feel like you need to explain a series of algebraic manipulations like this, some of these little arrows that I do are reasonable steps. So this is arithmetic. This is an algebra fact. This is the definition of this guy, right? If you want to write these out with a little more prose, that's totally fine. I tend to just sketch proofs out like this with the arrows. Writing them out with more prose is actually really good practice, especially if your intention is to study maths. If your intention is to study engineerings, then the little arrows are probably sufficient. Good. Okay. All right. Let's see. There's another thing about cosines. Does anybody remember the thing about cosines?
The cosine of the angle between two vectors multiplied by the magnitude
Good.
is
So the dot product of two vectors is the product of the magnitudes times the cosine of theta, where theta is the angle between V and W. Good with that? Which means that for non-zero vectors, you can figure out what the cosine of the angle between them is pretty easily by taking the dot product and then dividing by the magnitudes. Yes? Okay. I'm not going to prove this because I believe that it's one of the exercises I assign. It is cool. You should spend a minute and fiddle with it. It is a consequence of the law of cosines. And this is what you see on math memes. The proof of this fact is left to the reader. Sometimes you see the proof of this fact obvious, check, which is mean, kind of condescending. However, would almost be reasonable for our little lemma here, right? Like before I started writing down the proof of this little lemma, you had largely, I think, the people who were paying attention had noticed that that was true. You guys with me on that? If you didn't notice, don't feel bad. Shit happens. Like the list of things that I've not noticed is much longer than the list of things that I have noticed. Okay. So I encourage you to try this. If you have questions about it, try next time or ask next time. Think law of cosines. And then ask yourself how you prove the law of cosines. All right. Let's see.
A little bit over
What?
time.
I thought I had till 12:55.
Well, the schedule says 12:45, which may be why some people have already left.
Oh shit! I'm a bad person. I'm sorry, guys. Okay, let's call it a day. So you now have the content for sections 1.1 and 1.2. So you should be able to start those sections. Oh, and I can